So for doing that first one there, x plus 3 times x minus 4, really what we're doing is we are multiplying everything in the first parentheses by everything in the second parentheses. And so when we do that, we end up with x squared minus 4x plus 3x minus 12. And then we look to combine like terms, and yes, we do have like terms here. And you notice the negative 4x plus the 3x will just give us a negative x, or negative 1x if you prefer, but that simplifies down to be just negative x. But we technically on this one could have even just gone straight to that, right? Because you'll notice our original problem up here, the x plus 3 and the x minus 4, that's just starting each parenthesis with x. And so we know that the two numbers that we end up with after we simplify, that this number in the middle is always what we get from adding those two numbers. And the last number, well, that's what we always get from multiplying those two numbers as well. And so I could have actually used some of the knowledge that we have from factoring in order to quickly go to that product. Could make our job a little bit easier. And I actually use that on the remaining ones for 2 and 3 as well, as you'll see. But before we get to that, a little quick basic reminder. If I gave you a problem like this, if it'll write for me here, there we go, 2 times 3 times 4. If you're going to multiply out 2 times 3 times 4, do you multiply the 2 by both the 3 and the 4? No. Because it's not like there's parentheses around it with like addition. It's only the addition and subtraction where we end up using distributive property. If you were going to multiply those, you'd basically multiply 2 times 3 and then take that result times the 4. Or alternatively, couldn't you actually start by doing 3 times 4 first? And then you could multiply that result by the 2. Because order doesn't matter when we multiply. And I actually use that to make my life a little bit easier when doing something like number 2. Because technically we could actually do this in multiple ways. I know a lot of people tend to go and multiply the 2 in first. And that's fine if you do it that way. Although it's not the way I'm going to do it, as you'll see in a moment. But please note that if you do multiply the 2 in first, it only goes into one set of parentheses. So like you'd end up with 2x minus 10, but that would just be times x minus 6. I don't multiply the 2 into the other set of parentheses. Just like when I have 2 times 3 times 4, I don't multiply the 2 by both the 3 and the 4. I only do 2 times 3, and then take that result times 4. It's the same idea. And then after you do that, you could then go ahead and multiply everything in the first parentheses by everything in the second parentheses. And that'll work. That'll get you the same answer. But I did mention I didn't do it the same way. I did this by first multiplying the parentheses together, because I thought that was going to be a little bit easier. Because I could just look at it and know that these two numbers have to add to give me my middle number, and they have to multiply to give me my last number. And I know that because each of my binomials here just starts with an x. It's not a 2x, it's not a 3x or anything like that, it's just an x. So I can use that to go quickly to that. And then I went ahead and multiplied the 2 in there. So then I distribute the 2 into every single term. But whichever way you do the multiplication, you should end up with this as your final answer. 2x squared minus 22x plus 60. Same kind of thing happens for that last one. You could start by multiplying the x in to both the x and the 2. But I didn't choose to do it that way. I actually chose to start by multiplying the parentheses, because I can do that fairly quickly. Because I'm looking at those two binomials, and each one just starts with an x, which means that my middle number must be negative 2 plus 9, which would be 7x. And the negative 2 times 9 is 18, so it's minus 18 there. That lets me get to that product a little bit faster, at least for me. Choose the method that you like the most, and then I can multiply the x in, and multiplying the x in is pretty fast. Remember that when I multiply x's, that means I add their exponents. So x times x squared, that's really x to the 1 times x squared, so that'll give me x cubed, and then it's plus 7x squared minus 18x. And that's our final answer again. Same answer you get no matter what order you did the multiplication. You could have started by multiplying the x by the x minus 2. Heck, you could even start by multiplying the x by the x and the 9 over here if you wanted to, leaving the x minus 2 alone. Doesn't matter. By the end, you'll end up in the same place. And so we practiced multiplying the 3 different parts together. Now we're going to be practicing what happens when there's more than just 1 or 2 terms. What if we're multiplying a trinomial times a binomial? And seeing how that works. One little detail before we get fully into it though. Notice up here that we're always going to need to write our answer in standard form. And it might be worth making note of what standard form means. Basically, standard form means that it's simplified and written in order from biggest exponent down to smallest. And so we're always going to give our answers in that standard form of biggest exponent down to smallest and simplified. All right, so to multiply this out, we're actually going to use the same basic method as we used when we multiplied 2 binomials. We're going to multiply everything in the first parentheses by everything in the second parentheses. It just means, though, that in this case, that means actually doing quite a bit of multiplication because we have an extra term in there. But we're still going to be multiplying everything in the first by everything in the second. How many terms should I expect to get out after doing all that multiplication? Well, if we multiply 3 things by 2 things, 3 times 2 is going to be 6, yeah. We should expect to see 6 terms when we're done, which, by the way, is a great way to check yourself, because the common mistake that starts happening at this point is that we do all the multiplication, but we accidentally skip one. And so it's a way that you can check yourself and make sure you counted for all of them. All right, let's go and do that multiplication. First step, we do the x squared times the x. So that gives us x cubed. I then have to multiply the x squared also by the 5. So that gives me 5x squared. Now that I multiplied the x squared into both, I'm now going to multiply this minus 3x into both of those terms. So we do that minus 3x times x, which gives me 3x squared. And then we do the minus 3x times 5, which gives me minus 15x. Now that I've multiplied everything through by the minus 3x, I now need to multiply everything through by the 18. And so we do 18 times x, so 18x, and then 18 times 90. Notice we ended up with 6 different terms there. That's what we're looking for. All right, now that we multiply it all out, we need to go into standard form, remember. In standard form, yes, it is biggest exponents first, and actually we kind of are there, except it does need to be simplified. So notice our exponents are 3, 2, 2. Well, I'm going to be able to combine those. I'm also going to be able to combine the x terms. Remember, they have to have the same exponents because the exponents stay the same when I do the addition and subtraction. And so I'm going to go ahead and combine those like, which then gives me x cubed plus 2x squared plus 3x plus 90. You'll notice at this point there are no more like terms, so it's already simplified. It's in order from biggest exponent down to smallest. And so then this is standard form. This then is our final answer. That's what we're looking for. You're done. All right, now for this problem, this was going to basically blend the different types of multiplications we've done so far. Because you'll notice that we are multiplying 3 things together. And in the end, we're also going to end up multiplying a trinomial times a binomial, like we just did in the last one. All right, so first up, a little bit of strategy is I take a look at the 3 parts to my expression here that I'm going to have to multiply out. I don't see anything that jumps out as one set of multiplication being easier than any of the others. So I'm just arbitrarily going to choose to multiply the first 2 sets of parentheses together first. Remember, I can only multiply 2 of them, and I save the 3rd one for later. So I'm going to go ahead and multiply the x minus 2 times x minus 10. And again, you can do that by going ahead and multiplying everything in the first parentheses times everything in the second parentheses. Or you can go straight to the simplified answer by remembering that those 2 numbers will add to our middle number and multiply to our last number. But either way, I hope that you would end up here. Sometimes the question that comes up at this point is, if I just multiply it out like this, do I have to simplify it before I multiply? Not technically, no. You could actually take that polynomial of 4 terms and multiply it by the binomial at this point, but it means you're going to end up having to do a lot more multiplication if you do it that way. By simplifying it first, you actually save yourself some work when doing that multiplication. So, I now have a trinomial times a binomial. Well, we just saw in the last problem how to do that, right? Multiply everything in the first parentheses by everything in the second. So go ahead and do that on your own first, and then we'll take a look at what that gives us. And again, when we multiply 3 terms by 2 terms, we should end up with 6 terms. And so that's the first kind of way that you can check yourself as you do that multiplication. Make sure you got 6 terms on that next line. Then we look to combine the like terms from there. So I see some squareds that can combine. I see some x's that can combine. So I go ahead and you should then end up with a final answer here of x cubed minus 15x squared plus 56x minus 60. All right, now this one goes straight to just saying write it in standard form, so we know what to expect there. In this one, though, you notice what's a little different compared to some of the previous ones is we got that squared in here. And yeah, that changes things a bit here. We got to deal with that first. Now, think about what will x minus 2 squared equal?
X minus 2 squared times x minus 2 squared.
I hope that you're not thinking x squared minus 4.
Oh.
Or x squared plus 4. I hope that that's not what you're thinking. Because remember, to square something means to multiply it by itself. So really, x minus 2 squared means that we're going to have to turn that into x minus 2 times x minus 2. And in order to actually find out what that equals, we're going to have to multiply those two together. All right, so this is what we're looking at then. We now have 4 terms, 4 binomials that are all getting multiplied together. And let's talk again a little bit about strategy here. When multiplying these, you got a couple options. One option, which I think is actually the longer option, is we could start by multiplying x minus 2 times x minus 2. And then we could take that answer and multiply by x plus 5. And then we could take that answer and multiply it by the x plus 3. That would work. But I think it's a little bit harder than it really needs to be. Because we can break it up into a couple pieces here. The way I actually like to approach it is I'll actually multiply the first 2 together, and I'll multiply the last 2 together to get those 2 answers. Then I can take those and multiply them after that. Saves me a step along the way. So go ahead and do that. Multiply the x minus 2's together first, and then multiply the x plus 5 and the x plus 3 together so we have just 2 sets of parentheses. So when you multiply those out, this is what you should be looking at. We end up with x squared minus 4x plus 4, and the other parenthesis, x squared plus 8x plus 15. Now again, I was able to go there straight away because each of our binomials starts with just an x, which means I just have to add the numbers to get the middle and multiply the numbers to get the last. So I was able to do that for both, but you could also do it by multiplying everything in the first parentheses by everything in the second parentheses. But do simplify it. Because think about what would happen if we didn't simplify here. You'd actually have a polynomial of 4 terms and another polynomial of 4 terms. If you multiply 4 terms by 4 terms, you would end up with 16 terms. It's a lot. By simplifying first, I'm doing 3 terms times 3 terms, which should give me 9, which is still quite a few, but it's not 16. So we can at least save ourselves some grief by doing that simplifying as we go. But now really I can't get around it. Now I really do need to go ahead and take these 3 terms and multiply each of those by each of these 3 terms. So multiply your trinomials and check that you get 9 terms out when you do that. All right, and then when multiplying those out, first thing you do is you do x squared times x squared. That ends up giving us x to the fourth. But make sure that you know why it's x to the fourth. It's because I'm actually adding the exponents. I'm not doing 2 times 2, I'm doing 2 plus 2 to get that x to the fourth. That's going to help you as you start seeing more and more complicated versions of these. And then we multiply through all of the rest to get 9 terms. Check that you got these 9 terms when you multiplied it out. And it's especially useful when checking these. Pay special attention to the signs. It's very easy to lose track of a sign somewhere in here, and of course it'll wreak havoc. Just like other types of problems we've seen, if you start having troubles with your positives and negatives, it's going to give you lots of trouble later. So just make sure you're taking your time with those. All right, we got one last step. We got to go into standard form, which in this case means doing the simplifying. The x to the fourth, well, it's going to stay in x to the fourth because it doesn't have any other x to the fourth friends around. But we are going to be able to do some simplifying on the rest. And with something as long as this, marking it up is a great way to help yourself. So like, I have 8x cubed there. I'm going to go ahead and underline any x cubed terms I have. So notice I have 2 of them. By underlining them, not only have I marked, okay, these are the ones that I'm combining, but I've also marked that I've already used them. So now when I go and start looking for the x squared terms, I don't have to look at quite as many. Now for the x squareds, I'm going to go ahead and put a box around the x squareds as a way to keep track of it. Nothing magical about the box, I'm just choosing something that's a different symbol. And so that tells me I'm going to combine those 3. But again, now notice what isn't marked. It's giving me less to have to look at and analyze, looking for the rest of the like terms. And for those, I just have the x's that are still like terms. I'm going to go ahead and circle those. Notice I'm always either boxing, underlining, or circling the sign that's in front of it as well. That just helps to avoid any possible sign errors from losing track of what it is. And so then that tells me what to combine. When I do that combining of the like terms, this is what we should get as our final answer. X to the fourth plus 4x cubed minus 13x squared minus 28x plus 60. And you're done, because that's standard form. We know it's standard form again because it's simplified and it's in order from biggest exponent down to smallest.